I called Jim and asked what the history might be of how well do Osmia lignaria tolerate very, very cold, wet conditions and for how long of a period of time. And is that going to affect their fertility, their egg production? What can I anticipate as being the outcomes of entering back into really cold, wet periods?
From the Oregon State University Extension Service, this is Pollination, a podcast that tells the stories of researchers, land managers, and people like you who are making bold strides to improve the health of pollinators. I'm your host, Dr. Adoni Malathopoulos, Associate Professor of Pollinator Health in the Department of Horticulture. Anybody who raises mason bees know that the last few years we've had odd weather when the mason bees are emerging and starting to build their nests. I know I get this question a lot. What happens when we have a number of consecutive cold days? Let's say a female lays an egg. What happens to it? Does it die? Does it just slow down? Well, I have the perfect two guests to answer that question. Ron Spendle is a master gardener at Washington County. You know Ron from previous episodes. He is really the guru when it comes to mason bees here in Oregon. And I'm welcoming back, I think for the fifth time, Dr. Jim Kane. Dr. Kane is retired from the USDA Bee Lab. He is a real savant when it comes to all the bees of the United States, but he has, over his career, spent a lot of time on managed pollinators, and together they've published a new paper based on the observations that Ron has made up in Washington County. So this week on Pollination, let's head into the cold as we literally, as fall comes, as we head into fall, are coming into the cold on Pollination this week. I'll start by saying, welcome to Pollination. You'll say, I'm so glad. What? This is not the podcast I signed on for. Well, welcome Ron and Jim to Pollination. It's not, you've both been on the show in the past. It's so great to have you back.
A pleasure to be here.
It's very nice to be here and actually have a visual contact.
It has been a while since I've seen either of you in person, but it's so great to see you at least virtually today. And we're talking about a new paper that you both published. It came out just a few months ago, and it focuses on a kind of central question of, Osmia lignaria and, the kind of what the temperatures it deals with in the spring and its implications. Something I think a lot of people who manage mason bees are really interested in, but also people who are interested in wild bees in particular, also interesting. And so maybe Jim, just to start things off, can you set the stage about spring bees, and can you talk about maybe the evolutionary benefits of being, a bee that emerges early in the spring,
Sure.
but also its costs?
Well, most of our native bees are solitary bees, not social. And many of them have only one generation a year. So they're only active as adults for 3 weeks. And there's the option from any time from when the earliest bloom of crocuses and willows to emerging for bloom of goldenrod. And there's costs and benefits to those exercising those different options for the species. And they're consistent, such that year after year, a given species emerges at about the same time, plus or minus. For spring bees, especially early spring bees, so we're talking at the time of willow bloom, maple bloom. At home, you might have crocuses flowering, or maybe even daffodils. At that early time period, any bee that's going to fly then has to be already transformed to an adult the autumn before, so that they are ready to go when it warms up without having to go through pupation and a bunch of development that is temperature dependent. Osmia do this. Some other spring bees do this. The advantage is that there's these, in the right places, there's a phenomenal amount of pollen and nectar available, like where Ron is working, where there's maples and willows in particular. And it's relatively uncontested because, in particular, the social bees, they're only, except for the honeybee, but for our native social bees, they're just represented by overwintering queens. And they're going to be at these floral resources too, but it's not going to be a whole colony's worth of bees. And all the summer bees haven't yet emerged. So it's relatively uncontested resources, which, as you'll hear in a bit from Ron, this allows in the right place for blue orchard bees to accumulate multiple brood cells per day. The downside, which is the topic that we were confronted with, is, as you know, at that time of year, especially in Western Oregon, but most parts of the country, there's a parade of cold weather events interspersed with glorious weather. And if they're wet and cold, it pins down the female such as you can't forage. And the question arose here, what happens to the progeny who are enduring that cold? Do they succeed? Is there a cost in mortality?
Okay, that's fantastic. So there are these benefits. A bee that emerges in the spring, there may be, if there are social bees like bumblebees starting out, it's just one queen. They don't have that workforce that we see out my window right now that is furiously looking for nectar and pollen, a lot of competition. But also those bees that emerge later in the summer, they still aren't there. So it's just they have these resources, early spring resources available to them. But on the flip side, they can face, as we had a podcast, I think in 2022, which is the year of this study, with Jerry Paul, who's a mason bee producer, who explained in that year it was cold and raining continuously. And so that benefit may be offset by this weather. Okay, that's fantastic. This research came together on that year. So Ron, why don't you set up the concern? You and Jim have a long-standing collaboration going back a number of years. So I imagine you picked up the phone and asked Jim a question of biology of what happens on a cold. Tell us a little bit about that conversation.
Sure. One of the things that's become fairly regular in the Willamette Valley, at least, is we have a fake spring. So we get into mid-March or late March, and we might have a week of relatively mild, warm weather, and people are wanting to get their mason bee cocoons out, and they're wanting to go buy new plants and plant them. And there's a flurry of activity thinking spring's finally sprung and it's time to get ahead of the curve. And more often than not, in the last several years, that fake spring ends and we go back into kind of an Arctic condition where it's cool and wet. And so one of the things that I've taught people in the classes is to try to find some shrubbery that looks like it's pollen and nectar ready. Two main varieties seem to be pretty accessible to most people. That's the Oregon grape, the Mahonia, and like red flowering currants. They plant them a lot in public gardens and parks around this area. So people can go and see if they're starting to bloom. At least they know that the climate is such that it's making the pollen and nectar resources available. So that kind of shows that we're really looking at what we can do. And then it's safer to put your cocoons out at that point in time. So in 2021, for example, it was a beautiful spring, very dry, pretty mild. Matter of fact, it was the driest spring in the state's recorded history, with records going back to 1940. Then in 2022, it looked like we had the fake spring. Pardon me. So we put the cocoons out after that fake spring had kind of ended and it was getting a little cooler. But the anticipation is that we would get back into spring-like conditions fairly quickly. Fairly quickly never happened. So we started to see females emerging from their cocoons, and then we kind of went into damp, very cold period. And I was really concerned after watching them for like 10 days to 2 weeks that there were females emerging, but they stayed pretty much hunkered down in the channels of the nesting trays. And they weren't foraging very much at all. And so I was really concerned that maybe I'd put them out and expose them to something that was going to be not only slowing them down, but possibly fatal. So in somewhat of a panic, I called Jim and asked what the history might be of how well do Osmia lignaria tolerate very, very cold, wet conditions and for how long of a period of time? And is that going to affect their fertility, their egg production? What can I anticipate as being the outcomes of entering back into really cold, wet periods? And that's where we kind of started looking um, at the literature. Jim has access to significant amounts of literature and data. And so I relied upon him for consultation as to how to proceed. And I continued to take daily observations of the nesting trays at Jackson Bottom Wetlands, where we have 4 nesting stations set up. Each station has 12 trays. Each tray has 5 routed channels in it that are 11.5 inches long. And so I go out there every day at the same time every day, and I can get 24-hour snapshots visually of what is happening. Has there been any progress in building nesting cells, new nesting cells? Do the females seem to be active at all? And so I was able to provide that kind of information to Jim as we discussed what the implications might be and how to kind of work with the data collection that I would normally have done year to year.
Oh, so this is great. And you do, I think people can listen to it in a previous episode, but you have these really great nest trays where you have plexiglass on the top and you can observe exactly what's going on in the cell, and also have years of data going back on these observations that allow you to do these year-to-year comparisons. Jim, what was in the literature? Was there this kind of a study in the field that people had done previously? What did we know? How did you answer Ron when he gave you a call?
Yeah, the only field evidence was a mention in a report about cherry pollination done by Jordy Bosch and Bill Kemp. And I distinctly remember it because we drove by that orchard on the way out to doing work in the Great Basin, and it had snowed the night before on the cherry blossoms, on the bees. And it turns out it was a banner year for cherry production, and the bees did wonderfully. So I knew that at least a pulse of cold like that, they'd survive. But otherwise, the literature is all laboratory and using incubators. And so I think there's studies from Japan, from Spain, from the US, and all of them started at room temperature and looked at egg development rate. And then they warmed them up and looked at how that further shortened egg development time. But of course, a spring bee is really not concerned about how it's going to develop at 80 degrees Fahrenheit.
Mm-hmm.
It's in fact, this issue right here is that colder is the issue. There was one study by a student out of Virginia working with the established Osmia cornifrons, and he put them at 13 degrees Celsius, which is cooler, and found that it delayed emergence. This was at constant temperature. And he found that at constant temperature of 5 degrees Celsius, they never emerged. But when they died, and did they die because they used up the yolk or because of the cold, we didn't know. So Ron had an experiment on his hands with the concern that he might lose a good deal of his productivity. But faced with the conundrum of, well, I've got bees who are flying, so if I bring the trays in to warm them up to get the eggs to develop, the bees are going to emerge. If I bring them in and keep them chilled so the bees stay put, I've got the same problem I have outdoors with all these eggs. So about the only thing for it was to continue observations outside, sometimes in rainy, cold weather at noon, in order to see how they performed. And I should point out, this is one of the advantages. You learn so much by tracking individuals, which is normally really difficult. Like with bees, if you individually paint mark them, you start learning about all sorts of variation among individuals. And in this case, because Ron maps the cells every day and maps where the new brood cells are and then tracks them, he didn't have to actually mark the eggs to know who was who, because he knew it was in shelter 3, board 4, channel 2, the third cell forward was provisioned 5 days ago. And he knows that for all of them. So it's a very powerful amount of insight that's gained as opposed to just summing them all up. And it was important actually for our analyses. So the literature wasn't helpful. On the other hand, we realized that, well, we'll find out. And we may find out, after 3 weeks, you start having egg mortality or not. And so that's where we proceeded.
So I guess it raises the question of what did you observe? What, Ron, when you were going out to these, and you had a data set from the year previous, as you mentioned, a kind of the opposite situation, a really historically dry year in 2021. So what did you observe? When did these eggs die? Did they, what were you seeing when you made your daily visit to your nest blocks and tracked these individuals?
It's not that I could visually confirm that they were dying. It's just that as I observed them and their activity, they were in extreme slow motion. The females, for the most part, stayed hunkered down in their channels. At times when I was there for the 2-hour window of observation each day, I could see that they had left their channel and gone out to forage. It was pretty cold. It was still raining pretty well.
Huh.
So their foraging trips seemed to be pretty short as I would sit and observe how long it took them to come back to their nesting channel. And everything just seemed to be in slow motion. There was still activity, but very, very, very slow, especially in comparison to 2021, where we were frequently seeing, 3 and 4 nesting cells provisioned in a 24-hour period. The bees were extremely active. It was almost, I almost presented a nuisance to them, I think, in my data collection, because I was having to pull the trays out and do my visual observation of it and charting everything on my data sheets and putting the trays back. And they were hovering around waiting for me to get out of the way, basically, and let them go on about their business. In 2022, if anything, it gave me the luxury of pulling the tray out slowly, looking at it for a long period of time to see what differences I could tell that might be occurring every 24 hours. So nesting cell production was extremely slow. It was lucky if they had produced one complete nesting cell in a 24-hour period. The provisions, they seem to provision the nesting cell to the same extent that they may have done in 2021. The pollen and nectar pile looked like about the same size as historically I would observe, although I didn't do any measurements in terms of physical size or weight. Visually, they just looked comparable. But they were just being produced very slowly. Those eggs, after they were laid, instead of rapidly moving towards the egg hatching, it was taking a longer period of time. So it was like watching a slow motion version of the film that I had watched in 2021. But there was still activity. And we decided to keep taking the data every 24 hours and actually seeing what the productivity was, what the developmental speed may have been, and then what the mortality may have been because of the extreme cold and wet period. So we just basically went through that whole process. And even though things are moving in slow motion, the survival rates appeared consistent with historic patterns. There didn't seem to be a high or excessive mortality rates connected to the events.
Let me get this straight. When you have these eggs that are sitting for that length of time, the mortality rate of the egg, it's not, and give us a sense of like how long they were in the egg stage when it, how extreme are we talking about?
In like 2021, the egg after it was laid would basically take like anywhere between 5 and 9 days to hatch, depending on whatever factors were involved. When we got into 2022, it was taking for some up to 15 and 16 days to
Wow.
hatch. So the development process was just going extremely slow.
And that didn't impact their survival. The eggs
No,
emerged. Okay.
Now, even,
it didn't
oh,
it didn't impact their survival, and visually there was no change. It's not the eggs changed color or developed any kind of a fungal growth on the outside, or there weren't any visual cues that would suggest something adverse was happening to them.
Jim, you were going to say something.
yeah, at the extreme, there were a couple eggs who sat there for 43 days.
Really?
And quite a number of them that sat there for 30 or more days, so a month. And lo and behold, they hatched. And as Ron mentioned, he kept track of them. This delayed their overall development because they had a very slow out at the starting gate, but the weather warmed up eventually, but still delayed their development. But as Ron pointed out, they over 90% made it to cocooning. So it was fabulous survival. It preserved their food too. As Ron mentioned, there wasn't visible mold, and apparently the provision didn't spoil because you had that great survival, indicative of good provisions. It just took them forever.
What about the rest of their development? So they emerged from the egg. Was that slower? Is it just the egg stage that was impacted, or was it, as you described, Ron, just every stage, the foraging, the cell construction, the egg hatching, but also the development to an adult? Was that also impacted?
It was impacted. It slowed it down significantly, but as the spring progressed, like the egg hatching took the longest period of time, but then after the egg hatched, were they devouring the pollen provisions faster or at a normal rate? And they were slowing. That process appeared to be slower, but the weather was improving because the spring was advancing.
Right.
So eventually they kind of caught up as conditions improved.
Okay. Okay, fantastic. Is there anything else that I've missed of the key findings of this paper? We've got the egg, we have the nest constructions being slowed down considerably from the 2 to 3 cells or more that you saw in 2021, maybe a cell. We have these eggs, when they were able to lay an egg and get a provision together, that egg slowed in its emergence, sometimes considerably, but the survival was okay. And then we have the development also subsequently not being impacted, maybe, catching up, as you put it, as we move through April and it gets warmer. Is there anything I've missed?
The one thing we couldn't monitor, not easily, is their floral hosts and their progress in flowering. Because it could be that the flowering goes blazing by regardless of how cold it is. And so when it finally warmed up for the bees to be able to forage, normally it had gone by. It didn't seem to be the case, but we don't have monitoring of it. But you can see that, say, with fruit trees and the like, that they slow down, flowering slows down. Blueberries are a good example.
Yeah.
And they're also they're in the same challenging time as the bees. And so essentially flowers are refrigerated and reserved for the bees for when the bees aren't refrigerated anymore. And everything proceeds accordingly, rather well, actually. But in order to monitor that, we would need a canoe or hip waders for the willows. And the maples, we would need climbing gear. So it would be difficult to monitor in this setting.
I can just see some young graduate students getting their pen and paper out as they ought to. That would be wonderful. I suppose this is great. This is a continuation of this great work that you've been doing, Ron, up at Jackson Bottom Wetland and in your county in trying to piece together the long-standing, maybe received knowledge showing that these bees are there's a lot more to them than meets the eye. And I guess I wanted to hear from both of you, maybe starting with Jim, just what are the broader implications of this work in understanding, spring bee development, maybe why certain Osmia species, is this a factor that might be limiting their northern ranges? What does this have to tell us about the biology of these bees? And maybe also, and Ron, I know you are the resource for, the state on the management of these bees. What are the implications for management? So starting with biology, what does this research kind of point towards?
Well, part of it conforms to research I've not published yet, experimental research, field research here in Logan, in which, somewhat to my surprise, winter cold, so it extends this further, winter cold for the overwintering adult inside the cocoon is not lethal, even at 10,000 feet here. The challenge the bees have is enough degree days of warmth from the onset of spring, which of course is later at higher latitudes and at higher altitudes, that there's enough degree days to complete their development before it starts to cool down again. And with a bee like blue orchard bee and these other osmias, some of them have, if the timing's right, they have the versatility to remain as a post-feeding larva and go into winter that way. And the second season complete their development. And there's evidence for that at high elevations with several osmia. However, if they commit to pupating and then it gets cold, they die. But it's not a case of, as Ron's now shown here, the egg stage can withstand those kinds of cold pulses from Arctic air masses and do just fine. So the limitation becomes, is it warm enough for me to finish my development from a larva to a pupa to an adult before it gets too chilly to have any more physiological activity? And that probably is a constraint for the northern end of the bees range.
They can't
The
complete their
southern
development if they start.
Yeah. At the southern end or at lower elevations, and in Utah, I can't get lower than, unless way down at the south, I can't get lower than about 4,000 feet. But if one were to go down to Tucson, for instance, in the foothills of the Catalina Mountains, it's been shown that you will incur mortality because it can be too hot. And so chilling isn't lethal, but heating is.
Mm-hmm.
And this may be an issue for cavity nesters who are above ground, as well as those osmia and megachile who are shallow nesters in the soil. They're under maybe an inch at the outside, 2 inches of soil. That gets really hot too, unless they're in the shade of a shrub. So, and that's probably the greater concern in terms of climate weirding and our adding CO2 and methane to the atmosphere, is that there's going to be starting to be a retreat of those species from their warmest locations when it gets too warm.
Yeah, that's well put. And I actually hadn't considered, I know that, we always consider these to be cavity nesters above ground, but there's a lot of species in this group that are below ground, but that below ground nesting isn't very deep, so they aren't really buffered.
Right. If you're shallow, you've got a problem. If you're down a foot or two, I don't think global warming by itself is going to affect bees nesting 2 feet underground, which a lot of bees dig down that far. There'll be other issues, water, flowering, drought, things like that in their magnitudes and durations that will ultimately constrain them, as it does today. But it's not going to be heating of the immature stages.
Fantastic, Jim. What about turning around to people, the enthusiasts and also the commercial producers of mason bees? What does this work? I guess it answers the immediate question of, will my bees die because it's cold? But what are some of the, Ron, as you've been thinking about this data and thinking about management implications, what does it point towards?
Well, I think one of the things for me personally is that I'm not going to stress the cautionary tale I usually tell at all my classes about the fake spring, that it's good to wait until you think it's past, but it's not going to be ultimately a fatal issue. You can go ahead and get sucked into the fake spring, still put your cocoons out, and they may have a ripple of cold, wet weather afterwards, but it's something that's definitely survivable. And I will now no longer paint such a bleak picture of if you fell for that, you've blown your mason bee project for the year. I think it's something that helps people. It should help people better understand kind of the cycle of how this works. Granted, the mason bees seem to be operating on a very specific schedule, and I can tell you the different stages and time periods roughly that occurs at, and you can go through all that, but it's critical that people understand how temperature and damp are really much more involved in the process than maybe we were accounting for, not detrimentally or fatally, but definitely affecting the developmental progress.
I suppose one thing that just occurred to me as well is that you've set maybe higher and lower expectations. I mean, you're an excellent manager of mason bees, and people may not have the experience that you do, but if we were to look at returns per female and the best year and the worst year, what does that kind of look like?
Well, I think that's one of the things that we showed in this study is that the productivity between 2021 and 2022, there was a definite drop in productivity. The same number of bees were put out each year. The number of cocoons collected at the end of the season were distinctly different. So it was about a 33% drop in 2022, but that drop wasn't so much a result of fatal issues impacting the bee itself. It was more the idea that there was only a certain amount of temperature and damp conditions that would allow foraging to occur. So the issue wasn't so much the biology of the bee itself, but external conditions, which just limited the amount of foraging activity that could occur.
I suppose for myself, the other thing that comes to mind is if there's a turn in the weather, they can come back. That if they may be in a holding pattern, and if there's a sudden shift to better weather, those bees are alive and those larvae are, on the pollen balls and things can accelerate. A slow start doesn't mean that the whole season is shot.
Correct.
That's good to know. Gives me. Well done. This is, again, excellent work. I know that this is just touching on the data that you've collected over the years, Ron, and I look forward to seeing more of this work. And this is going to be really useful for both people who are managing bees, but our broader understanding of bees. So thank you both for joining me today.
Thank you, Anthony. As always, you had marvelous questions.
Thanks so much. Thank you so much for listening. Show notes with links from each episode are available at the website pollinationpodcast.oregonstate.edu. I also love hearing from you, and there's a form at the website where you can pop in and say hello and give me feedback. If you want to support the show, remember to leave a rating on iTunes, Spotify, or whatever podcast mothership you use. And finally, if you have the means and you want to help support my lab's effort to document bee biodiversity in Oregon, visit OregonBeeAtlas.org and follow down to the donate button where you can make a tax-deductible donation to the Jerry and Judith Paul Native Pollinator Endowment. Every little bit helps. See you next episode.